Use synthetic division to determine whether the first expression is a factor of the second. If it is, indicate the factorization. If it is not, enter D and E. So in order to do this, what we need to do is divide the two polynomials. And the result of this division, if it happens to have a remainder of 0, that tells me that the one given is a factor of the second one. And also, since this is of the form of a linear whose coefficient is 1, that tells me I can use synthetic division. I just take this factor, set it to 0, and change that number into a 0, so -5. I'm just taking the opposite. And I divide that into the coefficients of the given polynomial. So this is 4x to the fourth plus 20x cubed. Do be careful here because you need to put a 0x squared because there's no x squared term in there, plus 3x, and plus 15. Now, going through the process of synthetic division, I'll bring the 4 down. 4 times -5 is -20. Add this column to 0. 0 times -5 is 0. That adds up to 0. 0 times -5 again is also 0. Bring the 3 down. 3 times -5 is -15, and that column adds to 0. Now, the result of this is this value here is my remainder, and because that's equal to 0, that tells me that x plus 5 is a factor. The rest of this makes up a polynomial. The constant term is this item, and the rest of these are multiplied by increasing powers of x. So, to wrap up, we can say x plus 5 is a factor since the remainder equals 0. And the resulting polynomial is going to look like this. It would be 4x cubed plus 3 times the original factor, x plus 5. So we can't just put this 4x to the fourth plus 20x cubed and so forth is equal to 4x cubed plus 3. That wouldn't make any sense. Because 4x to the fourth, there's no way that's equal to 4x to the third. That can't be equal. But it is equal to the product of 4x cubed plus 3 times x plus 5. If you FOILed these terms out, you would easily find that the product of these two binomials is in fact the original polynomial.